Hey everyone, in this video, I'll walk you through deploying SFTP Gateway on GKE Autopilot. By the end, you'll have a fully working SFTP service running on Kubernetes that you can connect to and transfer files. Everything we do today will be from a local terminal with the gcloud CLI and kubectl installed. I'll also link the full KB article in the description if you want to reference it later. Let's get started. So if you're not familiar with GKE Autopilot, this is probably the easiest way to deploy containers on Google Cloud. And the reason for this is Google Cloud manages the entire Kubernetes infrastructure. And here I have an analogy. Instead of containers, you have frogs, and instead of the underlying Kubernetes server infrastructure, you have lily pads. And let's say you scale out your containers horizontally so that you have two of them. GKE Autopilot will automatically provision two servers underneath to support your containers. And then let's say that you don't need your containers anymore. You can scale them down to 0, and then GKE Autopilot will automatically deprovision the underlying infrastructure. And here's another way to say the exact same thing. This diagram splits up the responsibilities between you and Google Cloud. So on the bottom half, you could see that Google Cloud is responsible for provisioning the underlying server infrastructure for Kubernetes. And Google Cloud is also responsible for the control plane where they determine when servers get spun up and when they get patched. The only thing that you're responsible for is configuration, which is the top half. You will be supplying a Kubernetes manifest file, which is a YAML document. And then when you apply this manifest file to Kubernetes, Autopilot takes care of the rest. Here's a diagram showing what goes into the SFTP Gateway container manifest. Starting with the backend pod, this is the SFTP service, which runs on Java. These backend pods can scale out horizontally depending on your workload. These backend pods are organized under a Kubernetes service, and then SFTP end users will hit a GCP load balancer, which proxies traffic to the backend service. There's also a second container for SFTP Gateway, which is the web admin portal. And this is what you use to manage your SFTP users. And instead of hitting the container directly, admins are first going to go through a GCP HTTPS load balancer, which will then proxy traffic to the web admin portal pod. As for the database, we don't want to put Postgres onto Kubernetes, but instead we want to use the GCP Cloud SQL Postgres service. And then all of the backend pods will communicate with the database service through a Cloud SQL proxy sidecar, which is really good at managing HTTPS certificates when communicating with the database. And then finally, all of the data is stored in a GCS bucket. So now that we have some context about what we're deploying, let's go ahead and dive into the command line. The first thing that we're going to do is set some variables. Here, I'm on my MacBook terminal and I'm going to paste in some commands. First, I'm defining a project variable, which is the name of my GCP project. And then I point my Google Cloud command line to this project. Next, I set a variable for my region. And here, I'm generating a password for the Postgres root user, which will look something like this. And then I'm generating a database password for the SFTP Gateway database user, which looks something like this. As for this next command, it's going to instantiate the GKE Autopilot cluster. And this command might take several minutes to run. Okay, it looks like the Kubernetes Autopilot cluster is done spinning up. Next, I'm going to get credentials to the Kubernetes cluster. And the reason why this is necessary is a lot of the Kubernetes management is done through a command called kubectl. But kubectl needs to know which cluster it's pointing to, and it also needs a set of credentials so that it has access to manage that cluster. And then next, I'm going to create the Cloud SQL database, which is a GCP service. So this command instantiates the database, and it'll take a few minutes to run. Okay, it looks like the database is done spinning up. Next, we're going to take the Postgres password that we defined earlier, and then we're going to set it as the password for the root Postgres user. Next, we're going to create the SFTP Gateway database user and set the password to the DB password variable we created earlier. Next, we're going to run this command, which just creates the SFTP Gateway database in Postgres. This next command gets a handle to the Postgres database, which looks something like this. So up until this point, we've deployed the GKE Autopilot cluster. We spun up the database and created an empty database with the database user. Before we start running the next few commands, I think it'll be good to stop and take a moment and first understand what it is we're trying to accomplish. So the backend SFTP Gateway containers need to have permissions to access the Cloud SQL database. And normally you would create an IAM user that has permissions to access Cloud SQL. But the problem is there's no way to apply an IAM account directly to a Kubernetes container. Now, what you can do is you can create an identity on Kubernetes and then apply this to the backend SFTP Gateway container. But in order to get this database permission on the IAM account, we have to create this extra resource called a workload identity member, which associates this IAM account to this Kubernetes identity. So we're going to run 3 commands. We're going to create the IAM role with Cloud SQL permissions. We're going to create the Kubernetes identity, and then we're going to glue them together with the workload identity member. And this is the first command, which creates the IAM service account. And then we grant this IAM service account the Cloud SQL permissions. And then this is the command that will associate the IAM user with the Kubernetes identity. Next, we're going to generate some secrets that SFTP Gateway requires. This is the client ID and secret for being able to make API calls to SFTP Gateway. And this is what they would look like. Next, we create a JWT secret that is involved with authentication. And that's what this looks like. And here we're generating some self-signed SSL certificates, which are located here and here. Next, we're going to start running some kubectl commands for deploying to Kubernetes. The first command here creates a namespace, which I'm calling SFTPGW, and all of the Kubernetes resources that we deploy will fall under the umbrella of this namespace. Next, I'm going to take the secrets that we generated and then pass them into Kubernetes. We're also going to pass in the self-signed SSL certs into Kubernetes, but instead of passing in password strings, here we're passing in files. And then we could check with kubectl to verify that our secrets were created. And kubectl is not going to show the actual secrets. It's just going to say that they exist. So in this folder, I have the self-signed SSL certificate files here. I also have a test file that we're going to use later for testing the SFTP connection. I also have a JSON key for granting permissions to GCS, which we'll use a little bit later. But the important file here is the Kubernetes manifest file. And to show you what it looks like, you'll see that this is in YAML format. Here we have a section for the SFTP Gateway backend container. And you can see that it's wired to some of the secrets that we're passing in. This here is the database connection for the Cloud SQL proxy sidecar. And this is that Cloud SQL proxy sidecar. And the backend containers are organized in a service, which is defined here. The SFTP users will be hitting this load balancer resource, which will then proxy traffic back to this backend service. And here we have the web admin portal container, which we call SFTP Gateway-UI. And it has the same client ID and secret so that the web admin portal can call the API of the backend using these same shared credentials. And this is the load balancer service that goes in front of the web admin UI. So in this Kubernetes manifest file, there will be some locations where you need to replace this placeholder text with a real value. For example, instead of saying your IP address, you will have to replace it with your current public IP. So here I have some sed commands, which will replace specific strings within the Kubernetes manifest file with real values. The first one is going to be replacing the placeholder database connection name with the connection name that we obtained earlier. The your project ID strings will be replaced with our project variable, and then your IP address will be replaced with the results of this bash command, which will get my current IP address. So I'm going to run this real quick. And then sed should replace these values in place for the Kubernetes manifest file. Once your Kubernetes manifest file looks good, this is the command that applies it to the GKE Autopilot stack. And you could see that it created several resources. It will probably take a few minutes for the containers to spin up properly. So we could use this command to check on the status. And then you can run this command periodically to keep checking on the status. So it looks like they're both running. Now that both the SFTP Gateway frontend and backend are both running, let's go ahead and test it. First, we want to connect to the web admin frontend, and in order to do that, we need to get the public IP for the load balancer. So with this command, it will give back multiple IP addresses. There's going to be a cluster IP, which is internal to the Kubernetes cluster. And then there's an external IP that we can connect to. So for connecting to the front end, we're going to be interested in this specific IP address. For the sake of convenience, I have this particular command that will query the IP address that we're interested in. And then you could see that it is the same as this IP address right here. So I'm going to paste this into my browser. This is just an information page, so you can click here. Bypass the self-signed SSL warnings. And this is the first launch experience where you can define your web admin user. So I'm going to call it Rob Admin and then type in my password and then log in with that password. So the first time you run this, you will be presented with two settings options that you need to configure. The first one here is we need to connect to a GCS bucket, which will serve as our virtual file system. Second, I need to register for a free trial license using my email address here. But for the sake of this demo, instead of registering with my email address, I'm going to pass in a license key that I have already pre-purchased. Okay, here I have a command that will apply my license file to my Kubernetes deployment, and I have a variable that I previously populated with my personal license key. So I'm going to run this, and it will apply my license parameter, and then it will cycle out my containers so that the incoming containers will have read that license file. So I'll give it a few minutes to do that. Okay, let's check to see if the license file has been applied. So back in the web admin portal, if I refresh this, it will no longer ask me for the license file, but instead it will say that my license has been applied. Next, I want to create a cloud connection which will connect SFTP Gateway to a GCS bucket. So under Add New Connection, I'm going to choose Google Cloud Services, which will take me here. You may already be on the screen based off your first launch experience. And I'm going to call this default. For the GCS bucket name, I have a demo bucket right here. And then for my IAM service account credentials to access this bucket, I have already prepared a JSON key file. In here, I have pointed this field to a JSON key that's saved on my computer. And to make sure that this works, I'm going to click Test Connection. And I should expect to see 3 green checkboxes, which I do. And then I'm going to hit Save. And then working my way backwards from settings to folders and then users. Under folders, I want to make sure that my root folder is pointing to my default cloud connection. And then that resolves to my demo bucket here. So far so good. Next, I'm going to create a test user. I'm going to name it Rob Test. I'm going to keep the home directory as the default setting, so it'll create a folder called /users/robtest. And then for authentication, instead of setting a password, I'm going to generate a key pair. And for the key pair, the public key is set here, and then the private key gets downloaded in my browser. And then I click Save. So let's go ahead and test this SFTP user. Now, the SFTP service is going through a different load balancer than the web admin portal is. So the IP address for the SFTP service is going to be different. So I'm going to run this command here, which will give me the IP address that we're interested in. And then I'm going to connect via command line to the SFTP service. So here are what the commands look like. So back in my terminal, what I did was I moved the private key that I downloaded from the web admin portal, and then I moved it into this folder. And then I also locked down the permissions for this key so that only the current user has access to it. Otherwise, the command line will complain about that. And then now I'm ready to connect as my test user. So it'll go SFTP and then username at IP address, but we're logging in via private key. So we have to do -i and then the name of the private key that we're authenticating. It's going to ask me if I trust the server host key fingerprint, and then I'll say yes. And it looks like I'm logged in. I can list what's in my current directory, which is blank. And then I can also upload a file. So if I look at my local listing, I can see these files, and then I can upload a file. I'll do this one, test.txt. And this file has been uploaded. And then if I do another ls, it shows that the file is there. And to prove that the file exists in GCS, I'm going to navigate to this GCS bucket. And then under this bucket, I have a default users folder. And then under users, I have my username, which is robtest. And then under bucket/users/robtest, I have my test.txt file. So that's it. Let's recap what we built. First, we created a GKE Autopilot cluster, which is fully managed by Google Cloud. Then we created a Cloud SQL Postgres database. And then we wired the permissions so that SFTP Gateway has access to the database. We used kubectl to deploy the manifest file, which provisioned the SFTP Gateway backend and admin UI containers. And this manifest file also deployed the load balancer services for connecting to both the web admin portal and the SFTP service, which we tested toward the end of the walkthrough. So the first time you launch our container product, you will register for a trial license, which supports 10 or so SFTP users. And then once you're ready to go to production, you can contact us to purchase a production license for SFTP Gateway. The full KB article is linked below with the complete manifest, troubleshooting tips, and performance tuning recommendations. Thanks for watching. If you have any questions, feel free to drop them below in the comments.